Here we go. Okay, so it's 9:01 for me at least. I think it's 10 o'clock for you in Finland. So I think that we can at least get started in the introductions. Can everyone hear me all right? I hope so, and I hope that you can see my screen. My name is Anton Gyllnhammar, and I work for F5. Been at the company for a little over a year, and I am a solutions engineer specialist, specializing in everything that has to do with automation, orchestration, and cloud. And that has then evolved into me taking on additional responsibilities around F5 in the north of Europe, where I travel around. I help our channel, I help our account managers in everything that has to do with these types of fields and questions. Usually what I do is that I do local workshops, both for customers directly and through our channel partners. But as you might have come across, the COVID situation makes travel quite hard. So this is the way that we can engage with you in these times. And I hope that this isn't any less valuable for you. But I am used to you doing these sessions quite interactively and listening to you guys on what you want to hear and what you're interested about. So I really, if you have any questions, if you have any input or whatever, please just speak out either through the chat or maybe we can unmute you so you can say what you would like to say, so that we can keep this interactive, because I'm here for you to talk about these things. And I can of course do a monologue for 1.5 hours, but it's might be more productive if we can get some conversations going as well. But basically, before we start, I just want to know, like, how is the previous experience with F5 in this group? I haven't been to Finland too much, to be honest. I know that our local partners there are so good, so I don't have to really. But basically, how is the familiarity with F5? I don't know how this poll is working, but not at all. Okay, so the response that I got was that there is not that much familiarity with F5. So before all of this, maybe we should go down a little bit of memory lane to really see where we as a company has been and where we are moving. And to do that, I really usually start with like this whole trip through time story. So just looking at like the history of different types of innovations. Before when I studied quite a lot of management, and I have brought my recollections of what I learned there into sort of a bit about what happens within IT right now. So in the 1700s, there was a guy called Eli Whitney. He created replaceable parts for the American Army so that they could replace and repair their weapons in the field, and they didn't have to redo a whole gun just because some little part was broken. Then in the early 1900s, Henry Ford innovated with his assembly lines, really making the production environment of an object, reproducible, creating stations where people could have a particular speciality doing exactly what they are designed to do. Toyota created something called the Toyota production system and created innovations such as just-in-time, and this was in the 50s. And these are all big innovations within industry and production, but there is really a red thread between these innovations. And I don't know, now it's hard to be this is done for a classroom, but through a webinar it's kind of hard. But the red thread that I'm searching for is lean, the history of lean. So all of these innovations, they are in the vein of lean, and I don't know how many are familiar with the lean concept. I think most of you are, but just so to clarify, this is a official description of actually what lean is. Lean is the process of minimizing cost, resources, time, energy, and creating the most value. And this is kind of broad, doesn't really say anything specifically, but I think that having this concept in the back of our mind as we start talking about these progressions within F5, the technology changes and everything that's happening within the industry, this will make more and more sense of why we need to talk about lean in such a broad spectrum. Going back to this timeline, like manufacturing was of course affected by these innovations. You had lean manufacturing, the people who didn't do assembly lines, those who didn't implement replaceable parts or do what Toyota did with their just-in-time model, they simply do not exist today. And these whole practices, they developed into the lean enterprises, with lean human capital, human management. That was a big thing in the 80s. And ever since the 2000s, lean IT has been a thing. And lean IT, that's not something that's new at all. We have big concepts such as virtualization and other big things that follow in the lean methodology. But I would like to argue that this whole lean approach to IT has kind of accelerated in the last 5 years, and now it has reached a point to where we actually needs to learn this method of thinking to the whole IT department, not only the project managers. An example of this and why this is really, really important is just looking at application capital. In this new world where we live in a more software-defined world. Everything is delivered through some sort of application over the internet. It's especially tangible now with COVID, how important it is for companies to have a digital presence. This is a quite recent example of how Netflix, a company who doesn't have anything physical really, they don't own any massive theme parks or have a media empire and sell toys and whatever. They just own a service that delivers something. They were valued more than Disney. So Disney themselves, they realized that, oh, we need to hop on this bandwagon, even though we are such a an empire in their industry, but that isn't enough anymore. That whole empire is built upon something that isn't really the things that driving valuation now. That is the digital presence, the digital application, and how you can deliver your content digitally to consumers all around the world. And this, I think, is a recent example and kind of a good example too, because Disney then themselves, they created Disney Plus just to compete with Netflix. But if we take this into consideration and we say that this is somewhat of a reality, that our digital capital is so important, that says a lot about how we need to drive our IT infrastructure and how we need to deliver that IT infrastructure. Before, when we talked about how to deliver an application, that could have been months. We could have a change window or a change weekend once a quarter where you fitted every change that you had, and it was then that you could deploy applications. But in this new world, if we derive our value from the digital capital, the digital application that we can deliver, that isn't enough anymore. We need to, for the more modern application, deliver something probably within days. And in order to be really competitive and cutting edge, then probably hours is the time span that we need to aim for in order to change these things. And these values, they change quite a lot on how you think about your IT infrastructure and what you want to emphasize your investments into. F5 has been in this world for quite some time. And F5 has delivered a product called Big IP. Big IP has been a very prominent network appliance doing stuff like load balancing and application security. But a problem with the Big IP approach from a legacy standpoint was that it was severely controlled by a separate team, a networking team or security team, where they owned this piece of physical infrastructure, this box that they had in their data center, and they were the administrators of that infrastructure box. And this is where all of this monthly change request happens, because if someone from the developer team or the app team wanted a change to be initiated, or they wanted to have something new deployed, they would have to go through these hoops. They would have to throw some work order over the metaphorical hedge to this other team. They would have to process it. And because we are moving at human speed here, because we are moving in these more traditional ways of working, this is much too slow in order to be competitive, in order to be driving that valuation that most people are actually looking for, and trying to drive down those times to not be months anymore, but to be even hours. So what F5 realized is that with our key infrastructure piece, with the network appliance that we deliver, we are a part of creating this divide between developers who are developing the application. And if we go by the example that I gave earlier with Netflix and Disney, the developers in this case, they are the ones that's driving the valuation of the company. If we say that a company's application is the thing that is driving a more and more, a bigger evaluation and bigger capital of that company, then money will be poured into that developer in order to create a better application. So it's in the company's interest to empower these people as much as possible, making them run as agile as possible and making them as fast as possible. So this divide can't really exist anymore if that is the case, because then these people will be seen as a hindrance or a stop sign for innovation and for the continued growth of the company. And that isn't really acceptable. So this divide is something that F5 saw as if we are in this scenario where we are a embraced product in the IT operations infrastructure, what can we really do in order to ease this and not really have this divide anymore, and approach the developers and give them the tooling so that we can innovate at a more faster speed. But that is not all. It's also about the challenges that comes to with more modern application architectures. I think that most of you have heard of the term microservices, but essentially what this comes down to is that developers have realized that there is a somewhat better way of developing application with smaller and smaller building blocks. And before, if you did something manual, let's say that you had a classic enterprise and you had very monolithic applications, the applications themselves, maybe you had in this case 8, a fewer amount, and you were doing manual labor in the application lifecycle. So you had change requests and you did deployments or whatever. And all of these different stages of the application, they could be handled manually. But as we start to adopt more newer ways of making applications, we're starting to see like that these stages really get out of hand when we start to scale them. If we want to do stuff manually, we would have to hire teams just to handle all of these change windows. And if we want to do it fast, it would be needing more team members as well. And if we're looking towards where we are going, if we're looking towards what developers want to do, then it becomes totally unmanageable by the end of probably this year, because of how fast the new architecture that developers are adopting and the benefits that they bring with them into the lifecycle management of an application. So operations really can't be a stop sign here. Operations needs to elevate these practices. But at the same time, we don't want everything to go just Wild West and everyone doing whatever they want. We still need to have insight into everything. Before, if you did manual processes, there was quite a lot of additional work needed in order to get the visibility and the security insight that you want into all of these applications and whatever is happening within their lifecycle. So the only way that we can really achieve the insight that we want into our application environment is by implementing better tools that enables us to do that and enables us to scale to that more microserviced type of application. And that is really the core tenets of F5 as a company, on where we want to be focusing our for future focus on. We want to help companies go from code to your customer as fast as possible, because that drives the value of the company. And we want to ease the way of how to handle the number of applications, because those are only going to increase year to year, but also making you able to have insight into all of those applications and insight into the entire application delivery pipeline. Now, looking at where F5 traditionally has been a player, it has all been within the data plane. F5 Big IP has been a very successful networking load balancer, doing a lot of application security, DNS security, being able to handle a lot of DDoS attacks. But what we realize also is that in this new world, if we want to give away control over those types of application services to other people, different types of operators within the data plane operate in different ways. it isn't just the same kind of people who go in and have the certification, knows how to navigate the GUI. Some other people, they want to integrate together with maybe an API call in order to set up that service. And other people, they want to have more of a no touch as a service approach, because that's the easiest and with the most accessibility for someone who doesn't have the knowledge how to set everything up. And that really is also where we saw that we need to focus our endeavors to really see, okay, how does the application lifecycle look like? What are the tooling that people want to have within these different stages? And how can we cater to all of the different personas within the company that operates within these? And quickly what we realized was that there is no company that looks exactly the same. We can't really pinpoint a network operator that they always in every company do the operations and the deployment. For some companies, they might only do the operations, and it's up to the development and deployment stages for the application developers or the DevOps people. And for the security and governance, that might be handled by security operators, but in other companies, that's by the business owner. And all of these different personas, they require different things from these services, whether they are a network operator and wants to do a deployment, or if they are an application developer and they want a deployment, they will do stuff in different ways. So we saw that we needed to cater to that, and we also needed to implement this DevOps mentality into our product. And I think DevOps, that's kind of been run into the ground recently with everyone talking about it, but it is a very important concept. And I really encourage all the IT organization who hasn't really looked into what a transformation into DevOps would mean for them to start to look into how they could reduce silos and how they could improve cooperability internally within the organization itself in order to drive and strive to be as fast as possible that they can be. But we really want our products to be embraced by every type of persona and be able to be utilized, because if we can deliver our application services to the most amount of people, then that company will get the most value out of our product as well. And that really is what we're striving to deliver the value to our customers that they expect from us. But if we want to start this DevOps journey and we want to start giving out services to people, then we need to start also looking into how do we do that? How do we realize this vision? So it starts about shifting control. And usually when I go out to customers and I talk to them about how they are implementing DevOps and how they are shifting control over app services, this doesn't particularly specialize to F5 and big IP, but it's more general. This can apply to any vendor. Most of the time what I see is that companies have created a sort of internal service service point or a service provider of some particular service. So it's centrally managed, it's owned by a couple of people, and for other people within the organization, in order for them to consume that service, they would use a exposed API or an exposed layer of interaction through some automation like ServiceNow or another type of exposed service delivery method. But ultimately, what that service is and how that is delivered is defined by the people who own the service. They own if it is physical infrastructure, they own that infrastructure, and they really decide what you can do with it. And they say, okay, this is mandatory and this cannot be done because of security policies and whatever. And this is a totally viable option. And there is nothing really wrong with delivering services in this manner if you do it correctly and if you do it in an open and very inclusive way. It can certainly improve the interoperability within the Icon organization, and I think that it really strives towards what DevOps is supposed to be. But there is some disadvantages with this method, and it's all about agility and it's all about speed. I think a big reason to why this hasn't been the fastest adopter of things and why there has been alternatives to this method of working is because we vendors and other companies were too slow to really deliver this method of working. And what happens if a developer or a cloud architect, they are pressured to deliver a feature or a service from the company itself, because that is what's going to deliver more value to their customers, what's going to sell more or deliver more valuation to them, they will go to some service that actually can deliver whatever they want. And that is where this whole, the story of some engineer just going to a cloud provider, getting the service that they want to have or they needed to have in that moment with their own credit card. This is where that whole myth started. But really, that is somewhat of a reality, sadly, that in order to be as fast as possible and be as agile as possible, there is really a need for some people within developer organizations or application DevOps organizations to own their own infrastructure, because then they can move as fast as possible in the way that they want to move, and they have the most control and the most operability of their infrastructure, because maybe their application is very complex and it's not easy to integrate with, but they know how to do it. So this other way of delivering self-control is actually by saying, hey, it's okay, so you want this application service, maybe it's a application security product such as a web application firewall. Let's say that you just get to own it, give out that piece of infrastructure to them and let them configure, manage and handle it themselves. And this has been demonstrated by the public cloud providers that this is a real need that developers want and developers need. And we realized at F5 that both of these shifting of control, both of these different methods of delivering application services is needed for a company to really be able to be as agile as possible, to deliver new applications or changes to applications as fast as they can. But we still do not want to create shadow IT here. We want to deliver these types of application services in a managed way where we still can have insight and where we still can have control for the people who actually are responsible for stuff like the security compliance and other issues that has to do with company-wide policies. So our real mission then was to deliver this method of working with our existing infrastructure and maybe start to build something that can deliver this way of working with a more managed interface. And if we start to map out really where BIG-IP was a few years ago, BIG-IP was such an integral part of F5, but we realized that it was really centralized for a NetOps personality. It was really centralized around that type of working. But as public cloud and these new application deployment methods started to gain traction, there wasn't really an alternative to do stuff that was more cloud native and where control was more decentralized to the developers. So we tried to build a bunch of this stuff, but ended up buying some of other companies in order to get this type of comprehensive coverage of all types of application use cases. And this means that, and you will see soon, that it doesn't really necessarily mean that every of these types of products that I'm going to talk about now are very exclusive and have their own very special functionality. Most of these products do have functionality overlap, but it is by design because they each achieve their own solution in an own particular way. First of all, we have the traditional BIG-IP F5 that is very feature rich. It's enterprise trusted. We also bought something called NGINX. So NGINX, we tried to build something that it was very similar to NGINX, but realized that we couldn't really beat the original in the way that NGINX was built. So NGINX is a very, very small piece of software that is designed for modern architecture, and it is already embraced by developers. I think that it's around 500 million sites right now that are using NGINX in some way in their infrastructure. And what we then also wanted to do is deliver cloud services, because we realized that this is a function as a service. It's the easiest way to consume. And for some of our customers, they really need that ease of consumption. They really need that click of a button in order to get some sort of functionality, and they don't have either the time or the knowledge to set up something very complex. Of course, it's a bit of a give and take. What you get in feature richness, then you give away a lot of the leanness of that type of application infrastructure. And if you go to the, what I would say, the most lean type of application service, you get less features. So it's really a give and take of what you choose depending on what your particular needs are and what your requirements are. But I also would like to ask, like, how familiar are you with NGINX today? I think we have a poll here. Yeah. So we have a bit not at all. So I'm going to go through what NGINX is so that we get a comprehensive coverage of all of these products. So what really is NGINX then? NGINX started out as a very, very lean and small web server. That was all it is. It was a guy in Russia who worked for a data center, and he tried to set up Apache web servers, and he realized that they weren't really performant enough to handle a lot of concurrent users. So he set out to create a own web server, and he created that and open sourced it. And it has kind of taken off, and I think today it is the most used web server in the world because of its performance and how easy it is to set up. So it really is embraced by a lot of the developer community. And what's realized later is that not only was it good as a web server, because of how it was built, it was very modular and easy to be adapted into other types of scenarios on how to direct traffic and so on. So it really is split into a very, very performant data plane that has a lot of features for being in such a small product. From a web server to content cache being a reverse proxy, a ingress controller or a load balancer for Kubernetes, a regular load balancer, it can be a web app firewall, an API gateway, and can even be an application server. However, it's important to know that there is separate offerings of NGINX. You do have the open source offering, which is a download and you get what you see approach, meaning that it's free, but there is no real support. And if you have any problems with it, you have to rely on the community to get extensions and fixes for it. Or you have the plus version of NGINX, which is essentially the open source version with a bunch of stuff added to it, including then a load balancer out of the box, a web app firewall out of the box, and an API gateway functionality out of the box, and it's all supported. On top of this, there is also what I think is very important, the control plane. So since NGINX is so small and since it's widely deployed within an IT infrastructure, means that usually you have a very, very large amount of installations. So you need a good control plane in order to keep that in check and really have manageability and visibility over the entire infrastructure that you have deployed. And that is where NGINX controller comes in. But this is also important to note, is that the controller can only control NGINX Plus instances. It cannot control open source instances. So if you want to have an infrastructure where you want to manage a lot of smaller infrastructure pieces using NGINX, and you want to have a managed control plane or a control plane that you manage, you need to have NGINX Plus for that to work. So the logical question then is really, okay, so what really is the difference between the open source and the NGINX Plus version? Well, to be quite short, because I don't want this to take up too much time and not to be too technical, the core NGINX and the open source version of NGINX can be described as being very standard. Everything that is within the open source version, everything that will be added to the open source is whatever is standard within the web sphere. So if, let's say that there is a HTTP 2.1 or an HTTP 3 coming soon, that will of course be implemented into the core NGINX open source. That will never stop be updated. We will still continue to update and revise everything that has to do with the open source version, but it will only be whatever is standard, and it's probably quite bare bones in comparison to the Plus version, because the Plus version, that's very, very focused on the enterprise functionality. So whatever feature sets that you require from an enterprise perspective for a production grade infrastructure delivery platform, that is really where we put our money for the Plus version, the paid version of NGINX. So not only do you get quite a lot of additional modules that is built by the NGINX teams, so you are not relying on community-made modules for stuff, meaning that they are more performant, more secure, but also you get support. And I think that is also very important to note, that you get professional support with the Plus version. And for anyone who is looking into automation, you actually get an API with the Plus version. You don't get that, among other things such as high availability support that is not native with the open source version, and a bunch of other stuff that for enterprise is really important. And on top of that, with the Plus version, you also get the ability to implement the controller. So for those who don't know, NGINX itself is not really that graphically impressive. It doesn't really have that much bling to it, and it isn't really made to be configured using some sort of GUI or made to have oversight from a centralized managed place. It's more about integrating well solutions. So if you have NGINX instances today, you would have to have integrated them with another solution to get metrics and analytics and logs and whatever. And with NGINX controller, not only do we deliver a management plane for how to configure infrastructure pieces, but also a plane for where you can get analytics, and a central plane for you to have interactions through API with your entire infrastructure. The way NGINX controller, this is a very, very new controller, and this is where the controller actually was released just a couple of months ago, and it is the first effort that is combined with NGINX and the F5 after the acquisition of NGINX, meaning that this is the real first product that is after the purchase and the when we took all of the developers and put them together in the same team. So how it is built is that no matter how you want to build your data plane with NGINX and how you want it to be delivered, you have one way to deliver the application across that data plane. And it's very application centric, meaning that it's quite agnostic on exactly how the infrastructure itself is built up within these different application security silos. It's more about what application do you want to be delivered there, and what kind of stage is that application in? Is it in production? Is it in testing? Is it in dev? And we can automatically set up shadow environments where you can do the penetration testing or whatever else you want to do before you actually can move that into production. So it's all about handling all of that for you. So getting your APIs and pipelines to integrate with this centralized managed control plane where you can configure everything and get the analytics, handle your APIs and get true API management if you deploy your NGINX as an API gateway, get the security and implement other ecosystems. getting self-service portals for developers who want to deploy their APIs using the API management tool, and getting teams to operate with whatever they want to operate in, depending on where their responsibility is for that particular corporations. If the NetOps are controlling the load balancer, or if that is the DevOps role for another application. So that really is NGINX in a nutshell. And I also, if you have any questions, please ask them. I went through this very, very briefly. I don't want to spend too much time here because we don't have too much time today. But NGINX, think it as a very, very small performant piece of software that can deliver stuff in a modern way for modern application architectures. Then we have the cloud services, and that really is also something that I think is very, very important to not leave out of this equation, because there is a value of having a service being just behind the web portal, and just with one click and a few configuration inputs being delivered and getting value out of that product from minute one. So we have, from FI's point of view, steadily been building out our cloud service presence with products, and we are continuing to develop products. And I think that if you haven't looked into some of these products for your application delivery methods, I strongly suggest that you go out and at least create an account on FI Cloud Services, because we do have a lot of free tier stuff. For example, you can have a DNS within the cloud services, and you get free up to a couple of thousand or 100,000 DNS requests a month or something like that. So you actually can get free stuff from this as well. But we deliver quite a lot of things, and how we have set that up is really to deliver the way of working that we described earlier, with empowering developers and architects to get their service and own that service, but maybe not in the same way that they might own an NGINX service. With NGINX, they might need to know how to operate a piece of infrastructure. They would know how to configure it and whatever. But with the cloud services, that becomes even easier, because it's just a portal where you just say that I want to have a DNS load balancer, or I want to have an application security WAF on top of this product. Right now, what we do have is quite a lot of products compared to 1 year ago when this actually started, and we are going to continue to add, I think, 6 more products this fiscal year. So keep a lookout on these cloud services, because I think they are really interesting, and they really do deliver additional functionality for modern application architectures. Just an example would be, let's say that you have a multi-cloud strategy and you want to have your application being delivered within both AWS and Azure, but you want to have high availability across those clouds. Of course, you could implement some sort of active, and then you would have to build your own application, how to sync that and whatever. But with cloud services, you can actually have a DNS load balancer that is gonna handle all of the HA across those multi-cloud environments. So you actually can have an active standby environment and not really be tied down to one cloud vendor and be ruled essentially by their rules. And adding on top of that, if you don't know how to create a WAF, a web application firewall, you can just essentially add our essential app protect or our behavioral app protect on top of that application, and suddenly you are protected against most web application attacks that is out there with a simple click of a button. Then also we have our recent acquisition, and this is also a cloud service, and that is Shape. We bought Shape Security in the close to New Year this year. So what Shape essentially is that it it's a very advanced bot and fraud mitigation service. It's targeted towards banking, retail, anyone that has a lot of presence where there is quite a lot of fraud attacks, bot attacks, and automated attacks. And Shape has really been a leader in that field when it comes to AI-assisted analysis and anomaly detection of traffic going to some sort of application. So how it is built is that you build it in 2 steps. You have a inline protection that is built with signatures, and then you have an AI in the cloud where you try to where Shape has a lot of behavioral and analytics on exactly how the traffic is behaving, and it is constantly adapting in order for the application to be protected against not really what a signature says, but how the attacker is behaving. But taking all of these products now and overlaying them over our earlier page here, BigIP, that was very, very performant. And to be frank, there is nothing wrong with BigIP. It's just that it's just catering, and it is very, very focused on a or a very specific type of situation where you want to have the control over something to be very centralized with a NetApp organization, and where you need something that is very, very performant, that has a lot of functionality, which is usually the case where you have a traditional application or more monolithic application where you have to use a lot of functionality in order to make traffic work and doing a lot of rewriting and application checking. But if we're moving towards applications that are more modern, that making this transition, then we start to come across strongly decoupled microservices where there isn't that need for that much features anymore. And that is where NGINX starts to come in, where we have this hybrid between you can use it on-prem, you can use it on hardware, but you can also use it in cloud, and you can also use it in a containerized environment. It's really up to you, but it's made to cater to that type of application architecture. It's not as feature-rich as BigIP, and it will never be. It's all about more the packaging. And as you can also see, it's quite a lot of overlap because they can do some similar stuff, but NGINX will never be able to do it to the same extent as BigIP can be. But if you look at, and this is quite a good example of comparison, if you just look at something like the image size of BigIP versus NGINX, we have a tower, our headquarters in Seattle. It's a skyscraper that's about, I think it's 50 stories tall or something. If we say that the BigIP image size is as tall as that skyscraper, NGINX image size is not 3 stories of that skyscraper. It's actually just 15 centimeters of that skyscraper. So it's quite a big difference in footprint. And that is really where the real value here is. It's all about the packaging, not really about the service. And then lastly, we have the cloud services. The cloud services is the most lean of all of these, catering to just getting an application service started if the needed requirements aren't that high, because they as well don't have quite the same functionality as you will get with the others, but they are the ones that is the most decentralized and requires the least amount of effort to get started. So why have we started to doing like this? Well, it all comes down to, like what I said before, the lean choices that we do and the leanness of these type of application services, and choosing the right type of application infrastructure for your particular application and for your team. Looking at this was a customer. They had a environment and within their data plane, they had all of these different vendors. They were using so many vendors, and it was tool sprawling. But why were they using so many vendors? Like, we have FI here. Why didn't you use FI for everything? Well, it all comes down to that FI was the best at handling monolithic applications. But looking down and looking towards, well, microservice application, then there were other tools that were more appropriate to that type of style of working and were more appropriate to the type of people that wanted to integrate and worked with that type of application. So it's all about the personas and it's all about the application. And we realized that different personas work in different ways. They integrate with in different types of styles. And that is why when we look at this data plane and looking at our offering now, we do have quite a lot of overlap and we do have a lot of these types of deployments of applications services within these different silos. In Ingress controller, you can use NGINX or you can use an F5. Within load balancer, you can use the NGINX F5 or the cloud services. Within app security, we have a bunch of different offerings, all depending on exactly how you want to deploy the application, who is going to work with that application, and how do they want to work. So this code to customer story becomes very important. Looking at, okay, these different data plane silos are important to me, and realizing where and how for each application. This is not something that is supposed to be done company-wide. This is supposed to be done application per application. Really looking at what is the lean way for me to use these application services. How do I use the least amount of effort, the least amount of time and resources to get the most value out of all of these services? So my real point here is to say that there is no company that is going to get the most out of the F5 just using one of these products. It's all about seeing how you can use all of this product in the best way for each application and for each team of that application. And also what we then can deliver, because if you take that story and you really embrace that and you say that, okay, we're going to utilize NGINX where NGINX fits best, probably more towards the developer side and giving control over stuff like the API gateway and Ingress controller to developers. We're going to keep the application security more centralized and handle with maybe a big IP that has more features of that, and we're going to offload some of it towards a cloud vendor. What you get is that it's a single platform where you can get quite a lot of visibility, insight, and you can orchestrate across this all of these different silos, so that you don't get bogged down within the different types of management planes where you have an environment like we saw earlier. And also, this is more towards where we are going and what the future plan of F5 is that since our whole platform then, our whole umbrella of features is going to be such an integral part of this data plane that it's quite unique for a company to have the insights into all of these different silos, so that we do have a unique position where we actually can correlate all of these faults into a single visibility and orchestration tool for you to use. Let's say that you have an application that is having a problem within its API gateway, or if it is an attack that is coming from the outside. There is no easy way today for a company that has a big tool sprawl and many different types of application within all of these silos to really get a complete vision and a complete insight into exactly what's happening, where they should start to work. But working with this type of mindset, with these types of product, you get an entire application data plane that you can have the insight and correlability into. And that is quite unique. So really, it's all about transforming an environment. And again, this is a actual use case of where we did a transformation for a customer, where they sat with a application pipeline that had so many different types of vendors within them. and each of them had their own management plane. So even starting automating this was such a hassle, because you would need to automate across so many different types of APIs, so many types of different scenarios and how you wanted that thing to be deployed. And really, it's all about simplifying that into an environment that more or less looks like this, where you have a single type of environment with a single type of infrastructure piece that is already embraced by developers. Developers already know NGINX. They probably, you are already using it without your knowledge because someone downloaded the open source version. They already know it, and they are comfortable with using it, both in their modern microservice application environment and their legacy application environment. And getting the ability to distribute this type of infrastructure, but just because it's so small, because you can actually give it out and have all of the developers have their own playground in the background, while still being fronted with a more centralized net and SecOps operated infrastructure, such as a big IP, that actually is the front door to your entire application delivery infrastructure, whether it is on-prem in a data center, or it's in multi-cloud, or it's in both at the same time. And utilizing, for those people who don't know how to set up all of this, to basically just go out and get whatever they want from a cloud service with the snap of a finger. At the same time, also then getting the insight and the visibility through the control planes that we deliver. And that is really what it is in a nutshell, really delivering a sandbox type of scenario where you get a maintained front door and a backend playground where everyone can move as quickly as they want to, easy to consume, cloud native, works within every environment that they want to. And really to set this into more of a realized perspective, this is a concept environment, and I've written here data center, AWS, Azure, Google, just because I want to emphasize the idea that this could be one of them or all of them at the same time. We don't care, because we can deliver the same type of infrastructure in an uncompromising way across these different platforms. So first of all, you would have your security zone, where you would have all of the different implemented security and traffic management functions that you would need in order to create a secure pipeline for your applications to go through. So everything from global load balancing to a web application firewall to DDoS and bot protection to external API management and API gateway, taking payment for if you are exposing your APIs to other people, actually being able to monetize those applications. But also, if you are using some other stuff, implementing them in the security pipeline, doing SSL orchestration and stuff like that. And this is especially important to block void traffic. If you are working within a cloud environment, this is very, very important to really deny the entrance of people who isn't supposed to be there. So bots, attackers, automated traffic, you basically are paying for that. So if you can reduce that, you're gonna reduce all of your cloud expenditures tremendously. And then we come to the backend, where we said that we can have different types of environment depending on what exactly is the team that is working with that environment and how do they want to deploy it. So we have for example, the old enterprise app. This is something that has been with us for a long time. It has been delivered with an F5 load balancer and an F5 application firewall for a long time. It sits in the data center. We can't really move it because of some restriction, but it is fine. We can still deliver it, and we can have the same front door security service for that application. So the next application, this is more modern. Maybe we made a more transition to modernize this application. We, instead of having an F5 appliance load balancing it, we have started to use NGINX as a load balancer, but maybe we still are utilizing F5 as the DDoS mitigator for this application. And maybe we're running this application in AWS, using AWS and still also utilizing the access functionality and the authentication functionality of F5 APM in order to access external application that integrates within this modern application. And then you have a more modern workflow. You're starting to look at Kubernetes. You're starting to look at something like a service mesh. Maybe you are utilizing your own vanilla Kubernetes environment, or you are starting to use something like the Azure hosted Kubernetes environment. Then you can choose really. If you want to have your Kubernetes environment fronted with a hardware appliance, you can do that with F5. Or if you want to have a very, very widely adopted ingress controller in the sense of a NGINX instance, you can have that as well. And for all of the east-west traffic within these environments, so the service-to-service traffic from microservice to microservice, you can utilize both NGINX and our own version of Istio, which is called Aspen Mesh. And for a totally containerized environment, maybe this is running within Google as a Docker container. You can use NGINX because NGINX can be run with it in the Docker. BigIP cannot be run within a Docker, so you're covered there as well. And then all of these environments are managed centrally with either BigIQ for everything that's to do with BigIP or NGINX that has to do everything with NGINX. And of course, for everything that you want to utilize externally, you have all of the as a service functionality, such as Silverline, such as Shape, such as the different type of F5 cloud services that we just discussed. And all of this can then be deployed individually for the teams that needs to work with their particular environment in the way that they want to work, either through API, either through GUI, essentially how you want to work in the way that you want to work. So really it's all about looking at BigIP and realizing that F5 and BigIP, it's not really synonymous anymore. It's all about that F5 is a compilation of different products, and it's all up to you on how you want to utilize those products in order to deliver a lean application delivery pipeline, whether that is through the regular old means using NetOps functionality, or if it's for the more modern application DevOps crowd. Is there any questions?
I will stop the recording now so we can have the questions open.
Yes.